So now I will implement the replacement operation in video group. So I'm going to the program editor, setting, train stream and around it, then setting, stay program, and setting, searching. I'm going to the specified program yet. Just in previous lectures, I added how I discussed or I wrote a code how to insert a node into a heap. Now we are opening that program for further operation. That is how to do the replacement of the root node with some new node. And again to make it after the replacement, again the heap will be constructed. So for that beginning of previous program, which I will. So as we can see, if we go to the main function, so already there is that I gave a choice that when there is when we press, this is the option. If I press 1, that means we want to do further insertion of a mail node. Now we will give second option, this press 2 to replace the root node by a mail node. So here I want to write that enter to replace and one thing and one thing that you have to show the replacement first when the root node only will be replaced from the heap, and the current node first will be placed at the current position, but after placing the root position, it may be that the heap structure may get lost. So we have to construct the heap once again after replacing the root node by this new node. So for that, the option is I have given here enter to replace, otherwise enter anything. So here the option is the option is also written there that if choice equals to 1, then insert else to it. Now here I will write another choice for replacement, that is else if choice equals to 2, then we will call a function which is just less. That function will be called, which will do the work of replacement. So now I have to implement this function replace. I have to write the code for it. So first we have to declare the function, then we will define the body of the function. So void replace and later function declaration, then we will define the function body void to replace the field. So before then first it will check whether there is an if is not empty or not. If it is empty, then we cannot replace any nodes from the list, but if it is full, if any element is there, maybe one element or whatever, if any element exists in the heap, then we will replace the root node of that heap and place the new node into that root position. So first it will check if and whether there is at least one element or not into the heap. So if array 1 is not equals to non-character, that means that there is at least one element. There is at least one element into that heap. This is non-character. So if array 1 is not equals to non-character, in that case, what I will do the operation of replacement. But if array 1 is not character, then I will print the proper message by printf that it will tell that the message will tell that the heap is empty, so no root cannot be replaced. Heap is empty, it is empty, so root replacement operation cannot be done. Replacement operation cannot be done, not cannot be done. So that user will get to know whether replacement operation, why it is not happening. It is due to emptiness. Okay. So it is that. But if everyone is not equals to null character, then there is at least one element in the here. At least one element. So first of all, I have to ask from the user the what will be the value of the new node. So I'm using a variable num. Enter will give the values to this num, which will returns the root value in the root position. So here I'm asking from the user that is to enter new node for replacement. But will ask from the user for new node to enter. So after that, the user will enter the new value by scanning function. So scanning percentage G and conversion num. So after entering the value, I will place it at the position of the root node, which is at the index 1 position of the array. So I am assigning a root to it. Now after placing that, maybe the heap structure may be lost with that new root position, the element has less value than its proven. So if it is less value, then that new node will know next level, and the child at the next level will come to root position. So to do this, we move downwards. So actually, for the plus count operation, we are moving downwards through the we were moving downwards through the tree. So to implement the downward movement, I am using a function which is move down. So which is move down, and here the which element will be checked for downward movements or root element. So I am passing the index value of root element as the parameter of the function. Now on the next lecture, I will discuss how to write the code for mesh down. Okay.
Thing.